All right, in this lesson, lesson 8 of module 4, you're going to be able to relate a fraction of a set to repeated addition interpretation of fraction multiplication. Sounds a lot of complex language there, but we're just going to be able to show how a fraction of a set can be used as repeated addition and then turned into a fraction multiplication. Let's get started. All right, we're going to go over to number 2, and they want us to rewrite the following addition expressions as fractions shown in the example. So let's look at the example really quick. 2/3 plus 2/3 plus 2/3 plus 2/3 equals, they're saying that the denominator would stay the same, the thirds, and then in the numerator, since there are 4 2's, we're going to multiply 4 times 2 to get 8/3. All right, so easy, follow the pattern. First one we have, let me zoom in. We have 7/4 plus 7/4 plus 7/4. So we know that the denominator is going to stay the same, so we have fourths. And the numerator, we're going to go ahead and multiply. There's 3 of them, so we're going to go 3 times 7, which then as a fraction would be 21/4. Which we can take it one step further and say 21/4 is bigger than a whole, so I can go ahead and pull out a whole. I can go ahead and pull out another whole because that is now 8 wholes. I can pull out another whole because that would be 12/4. Oops, not equals. And I can pull out one more whole because we have 4/4 plus 4/4 plus 4/4 plus 4/4. So that means we have 16/4. And I can even pull out one more whole because then that would be 20/4, which means I have 1/4 left over. So I'm going to squeeze that in. So remember, all of these 4/4 equal one whole. So how many wholes do I have? I actually have 1, 2, 3, 4, 5. So I have 5. I'm going to erase this 2 that I was about to write. I have 5 wholes and I have 1/4 left over. All right, let's go to 1b. 1b, we have 14/5 plus 14/5. So that means our denominator stays the same, and we're going to multiply. There's 2 14s, so we're going to multiply 2 times 14, and that would give us 28/5. And now I can go ahead and pull out some wholes. I can pull out at least, there's one whole, and then here's another whole, so I have 10/5. And then I can pull out another one, which is 15/5. And then I can pull out another whole, which is 20/5. And I'm going to write it down here. I can pull out another whole, which is 25/5. And I can't pull out another whole. That means there's going to be 3/5 left over. So how many wholes do I have? 1, 2, 3, 4, 5. I've got 5 wholes and 3/5. And the last one for 2, we have our sevenths will stay the same, and then we have 3 4s, so we're going to go ahead and multiply 3 times 4 to get 12/7, which then means I can pull out a whole, and I can't pull out another whole because that would be 14/7, so that means I have 5/7 left over. So this is a whole right there. So as a mixed number, I can say 1 and 5/7. All right, let's look at 3. 3 says they want us to solve and model each problem as a fraction of a set. Right here is a fraction of a set. And as repeated addition. Here is the picture for repeated addition. And so we have kind of examples to kind of look after. So let's go ahead and say, okay, 1/2 times 8. Now that means 1/2 plus 1/2 plus 1/2 plus 1/2 8 times. So we can go ahead and say our denominator is still going to be halves. And I'm going to go ahead and multiply the 1 and the 8 together as my numerator. And so I get 8 over 2. And don't forget, remember, this also means 8 divided by 2, which we can do really quick and say, okay, this also means 8 divided by 2, and I know that's going to give me 4. So as a fraction of a set, remember this multiplication means of. So I can say, okay, I'm looking for 1/2 of 8. Well, this whole must be 8. And I'm looking for 1/2. That means I split it in half. And here's 1/2. What number would go in each box evenly? 8 goes into 2 boxes, and the number would be 4, which then proves that the answer we have over here is the same. Same thing over here. We're going to go ahead and just show that we're going to go ahead and take the 8 wholes and multiply it by the 1. So that's 8 times 1. And then our denominator will be 2, which means we have 8 halves. And that actually equals 8 halves is 8 divided by 2, which is 4. Now this one we're doing repeated addition. What that means is we are going to take 1/2 and we're going to add it for 8 times. So that's 1 time. Do another box, that's 2 times. Do a third box, that's 3 times. That's 4 times. That's 5 times. 6 times. 7 times. 8 times. So we have 8. And then if I add these up together, let's think about this. Do a little highlighter, okay? 1/2 plus 1/2, that's 1 whole right there. Another half plus another half, that's another whole. Then you have another half plus another half is another whole. And the last half. So it looks like we have 4 wholes, which then proves that our answer 4 is correct. And I can go ahead and put the number 4 up on top. All right, let's go ahead and do 3b. Let me zoom in just a little bit so I have more room to write. All right, so I'm just going to go ahead and say, follow the pattern. The 3 and the 10 is going to get multiplied together. So 3 times 10 is on top, 5 is on the bottom. So I end up with 30 over 5, which also means, remember, 30 divided by 5. Well, 30 divided by 5 gives me an even number, and that's going to be 6. Now, to show a fraction of a set, we're going to go ahead and do my tape diagram. The number 10 is going to be up on top. And we need to divide it into fifths. That means 4 lines. And I need to figure out what 3/5 are. So 3 out of the 5 boxes. We're trying to figure out what 3/5 times 10 is, which we know is 6, but we're going to have to show it with our diagram. And so we got to think, okay, if I have 10, I have to divide it evenly into 5 boxes. So that's 10 divided by 5 would give us 2. So the number 2 goes in each box. And then if I'm only looking at 3 out of the 5 boxes, 2 times 3 would give me 6, which then matches our answer right there. Let's move over to the second part of B. And quickly just say, there's more practice. 10 times 3 will be what's in the numerator. And then 5 is our denominator, which we get 30 over 5, which we know that 30 over 5 means 30 divided by 5, which is 6. And so now what we're going to do here is we are going to show repeated addition. And I'm going to draw my first box. This first box is going to be 3/5. My second box is going to be 3/5. My third box is going to be 3/5. Fourth box is going to be 3/5. Fifth box is going to be 3/5. And I have to do this 10 times. There's my sixth box, my seventh, my eighth, my ninth, and here's the last one, and 10th. So if I were to have to add all of these up, 3/5 plus 3/5 plus 3/5 plus 3/5 plus 3/5 10 times, I would get 30 over 5. I would get 30 over 5. Let's say these, I'll write my number on the bottom. These 10 boxes would be 30 over 5, which also means 30 divided by 5, which is 6, which matches that. Number 4, they want us to solve each problem. So I'm going to put solve each problem in 2 different ways, as modeled in the example below. So I'm going to kind of explain the models or the examples. The first one, we're just going to go ahead and set it up and say, okay, 14 times 3, zoomed in really quick. I have 14 times 3 up on top, and I have 7 as my denominator. So now I got to figure out what 14 times 3 is. So I'm going to do a little side math. I'm going to say, okay, 14 times 3, well, 3 times 4 is 12, and 3 times 1 is 3, plus 1 more is 4. So as a fraction now, I have 42 over 7, which also means 42 divided by 7, because I know if I do 42 divided by 7, I will get a whole number with no remainder, and that is going to be 6. So remember this work that we did. Now we're going to go over to the next one, which is the same problem. But what I'm going to teach you here, and you might have already learned, that we can actually, let's first set it up first before I explain. I have 14 times 3 up on top, and 7's on the bottom. Now what I'm doing here is I'm trying to find, in the numerator spot, I have 14 and 3 to pick from, and the denominator I only have 7. So I'm looking for what two numbers, or what number is compatible with 7. So I know that 7 and 14 are compatible numbers because I can count by 7s to get to 14. So what we're going to do is we're going to actually try to divide the 14 and the 7 by a number that they both share. Now, I know if I count by 7s, I can get to 14. So I can say, okay, well, 14 divided by 7, so I'm crossing this off, 14 divided by 7 would give me 2, which then I can also do 7 divided by 7 would give me 1. And so what I just did is I took those big numbers and made them smaller by dividing them by a number, the number 7. And now I have 2 times 3 on top, which is also, and 1 on the bottom as a denominator, which is actually 6 over 1, which actually also is 6 divided by 1, which is the number 6. So 2 different ways, I'll zoom out really quick, they're the same, 2 different ways solving the same problem, getting the same answer. The second way that we're doing it might be helpful when we get to some bigger numbers down below. So let's try them out. So I'm going to zoom into B, and we're going to do B. Let's follow that same pattern. I know that my denominator is going to be 4, and I know I'm going to have to multiply the 3 and the 36 in my numerator. So a little side math, I'm going to have to figure out what is 36 times 3. 3 times 6 is 18, and 3 times 3 is 9, plus 1 more is 10. And so now I have 108 over 4, which also means 108 divided by 4, which now we're going to have to do some little long division down below. Try to kind of keep your work kind of nice and neat so we don't go into the next problem. So I'm going to go ahead and do a little long division. Well, you know what? I'm going to go ahead and do my partial quotients because I know that, I know that 4 times 20, that's easy, right? That's 80. So I can use 80 right now, okay? And say, let's just use 80 and put the 20 out on the outside and subtract. I got 8 and 10 minus 8 right here. This is 10 You don't need to go borrow. You can say this is just 10 minus 8, and that's 2. And now I have 28 divided by 4. Ooh, now I'm getting closer. I know 28 divided by 4. If I count by 4s, or I look at my multiplication chart, I will see that if I count by 4s, I can get to 28, and that means I did that 7 times, and I have no remainder left over, so my answer is 27. So the answer to this problem is 27. Now let's keep that in mind when we go and do it the second way. Let's see if we can eliminate some of the work that we just did here on the same problem again. So I'm going to go ahead and do the same thing. 3 times 36 up on top, and 4 is on the bottom. Now, before I even multiply 3 times 36, I know that 4 is compatible with 36. And the reason I know that is because I know if I count by 4s, I can get to 36. So that means I'm going to divide my 36 number by 4. 36 divided by 4. If you don't know that, look at a multiplication chart. That will give me 9. And then since I divided 36 by 4, I'm going to divide the denominator by 4 too. 4 divided by 4 is 1. And now I went ahead and have a new problem. I have 3 times 9, and I have the denominator as 1, which is 27 over 1, which is also 27 divided by 1, which is the answer 27. Oops, go back to that, which is 27. Now let's compare what we did on the right to what we did on the left. Now I can already see that by doing this method of more of, basic math facts of trying to get these big numbers smaller, we did not have to do 36 times 3, and we did not have to do long division. So we eliminated 2 things that we did over here that we did with one small thing to get the same answer. So I don't know about you, but I'd rather do this than have to do extra work right here. All right, let's actually go ahead and do 4D. All right, 4D, let's go ahead and say, okay, I have 9 times 32 up on top and 8 on the bottom. Now I'm going to have to go ahead and multiply 32 times 9 first, because 9 times 2 is 18, and 9 times 3 is 27, plus 1 more is 28. So I have 288 over 8. And now I'm going to have to do some division, because 288 divided by 8, I don't know off the top of my head. So I'm going to go ahead and say, okay, 288 divided by 8. Well, okay, let's think. 8 times 10, that's 80. I know that. What if I doubled 80? That would be 160. 160 would work, right? Let's just use that, because I know that 160 would mean I counted by 8s 20 times. And now I can subtract. I can go ahead and do 8. 8 minus 6 is 2. 2 minus 1 is 1. So I have 128 now. Well, I can't use 160. Well, maybe I just go ahead and use 80. That means I counted by 8s 10 times. And I'm going to go ahead and do 8 minus 0 is 8. And some kids are like, oh, 2 minus 8, I need to borrow from the 1. But guess what? If you borrow from the 1, it's just going to make it 12. So instead of borrowing, just say, okay, now I really only have 12 minus 8 to do. 12 minus 8 would give me 4. So I have 48 left over. Ooh, I know that 8 can go into 48. I can count by 8s 6 times, because 6 times 8 is 48. And then I have 0 left over. That means I counted 8 6 times. So I'm adding those numbers up, which would give me the answer of 36. So the answer is 36. So we did 2 things. We had to multiply and do a little long division to get the answer. Now let's see what we would do by doing some little easy work before we get our answer. So same thing, 9 times 32 over 8. I know 8 is compatible not with 9, but 8 is compatible with 32 because I can count by 8s and I can count by 8s 4 times to get to 32. So think about it, 32 divided by 8 would give me 4. And 8 divided by 8 would give me 1. So I used 8 to divide 32 and 8 by to get smaller numbers. Now I have 9 times 4 over 1. Well, 9 times 4, we should know that it's 36 over 1, which then we know that 36 over 1 is the same thing as 36 divided by 1, which is the same thing as 36. So look at that. Let's compare. A lot faster on the right-hand side than we did on the left-hand side because look all that work that we had to do because we had the big numbers. So if we kind of do some of the, the work inside the problem, we don't have to do all this work on the left-hand side. All right. Nice job today, guys. That's lesson 8 for module 4. I'll see you on the next video.